My vision about parallel programming future is that within 5 to 10 years everybody will do it. Right now we are talking about it, and a lot of people are gaining interest in that. I can see at all my sessions that more and more people are actually raising hands that they have looked at that and they are interested in that, and I have more and more people actually attending my sessions when I'm talking about parallel programming, and that makes it a very hot subject. If you look at object-oriented programming 10 years ago, we were in the same phase that everybody was talking about, but nobody knew exactly, or nobody was using it. There were a lot of stuff, happening behind the curtains, and they were a little bit afraid of using them. Now, I don't think there is a programmer out there that cannot say anything about object-oriented programming. And looking at the mainstream, every single hardware manufacturer is looking into that, and everybody realizes that we cannot increase the frequency. We will just have to put more cores into one machine. Nowadays, I think you can get like 8 cores in one chip. I just bought a Core i7 processor, and it has 4 cores with hyper-threading. So if you look at them, you get like 8 logical processors in their machine. Then it's a fact. Actually, it's now. It's not. It's not something that would happen within 5 to 10 years. It's now. It's the present. So that's why we have to do that. Where we have to embrace the parallelism. The general programming is the parallel programming. Actually, the real future is something that we really have to look into it. And if so, how can we do that? When a thread doesn't have anything to do because he has an empty queue, we'll go look at the neighbors. Which one is the most busiest thread doing tasks? And we'll start steal tasks from them. And it will steal a task and start running it, and maybe this one will create new task, and then it will have some job to do, and then it will go again and again and again. And I had with me Don Syme, the architect behind the F#, and I had with me Steve Teixeira and Keith Yadlin, I think it's his name, working both of them on the parallel programming team in Redmond, and they are here actually delivering some sessions about parallel programming as well. And that's what was the main reason of discussing that. We had someone actually having the vision of parallel programming, that was Steve, and then we had Don talking about the functional language and how they fit into this this new constellation of languages and technologies that are available. And then Keith was talking about the language general, because that's his specialty, languages and integration of those into Visual Studio. One interesting point that came up actually was that Intel is doing the same kind of work in this area, and what I heard, and I hope that's true, it's that they are actually talking about having a common platform, or somehow integrate their work together, so to make those stuff available for the programmers, especially if you look on a native side of the things. When you can use all kind of TBBs, OpenMP, MPP, or the concurrency runtime, or the PPL, you write your code and you don't know in the end which one you are using, if you are using both of them or if you are using a combination of them. So it could be quite challenging. So by having a common vision, common product, or that will be a very very good thing. And I think Intel has done a very good job for a very long time trying to create an awareness within programmers actually with all their products and the product suites that they are available. I can remember 4 years ago, or three years ago during the summer, they had a whole summer with shows about parallel programming, inviting a lot of people working within the area to just give their version of their vision of the parallel programming and what the state was on parallel programming. And I know that there is a lot of research going on at Microsoft and at Intel, so they are working on this area. Intel, obviously, for the very reason that they have the hardware and they need to make programmers use the hardware the way it is supposed to be used, and Microsoft because they realize that if they put more features on a box, they will need to do those kind of stuff, and if programmers start to write applications using those kind of stuff, it needs to be done the right way. If you ask yourself when do you have to start looking into parallel programming, I'll say yesterday. If you are wondering how to start, There are a lot of libraries. If you look at Intel, they have a whole site about concurrency, intel.com/concurrency, I think it's called, or /GoParallel it's called actually. We have a lot of tools nowadays available, both from Intel, but we have a lot of tools from Microsoft. Visual Studio 2010 actually will come with a lot of tools built in the Visual Studio, so we could actually work with them and go create our parallel programming applications. If you go on the GoParallel site at Intel, then you'll get a lot of resources, a lot of video, a lot of information about how you can actually think about. There are a lot of available courses, free available courses online that you could download and look at them. There are books out there. I mean, there is Timothy Masson's book called Patterns of Parallel Programming, which is a very insightful book about how to think about your application and how to try to parallelize it. Microsoft has as well a very broad site, their msdn.com/concurrency site that you could look, and you'll get once again a lot of videos, a lot of materials, a lot of examples, blogs that you could use and then start looking into that. You'll have books from the book from Joe Duffy, for instance, if you are specifically interested in Windows programming and want to look at how concurrency is managed into Windows programming. I don't know. You have to start thinking about your application in smaller terms. You know, I mean, even though it sounds a little bit crazy, you know, I mean, we are thinking big, but I'm saying thinking smaller terms, because what you want to do is you would benefit by breaking your application into smaller chunks and trying to work that way instead, because then it's easier to parallelize and it's easier to use the resources made available for you. Please don't forget to fill out the evaluation, because you might win an Xbox 360 Elite, so please do that. Thank you very much.